Something is hiding inside a star. From a distance, it looks ordinary, a tiny point of light buried among billions of other stars. But when astronomers studied it closely, something was wrong. Its behavior suggested that whatever was producing the light might not be a normal star at all. And if that interpretation is correct, this object could be something far stranger, a black hole hiding behind the appearance of a star. The mystery begins with an object known as Thorne-Zitkoff object candidates and black hole-like stellar systems, where extreme gravitational behavior can make a compact object difficult to distinguish from an ordinary stellar companion. But there is an even stranger possibility. What if the object we think is a star isn't actually the main object? What if the visible light is only the surface of a much darker system? Astronomers have spent decades searching for stellar systems containing black holes that are difficult to detect. Normally, finding a black hole should be relatively straightforward. A black hole itself emits no visible light, so scientists look for what it does to everything around it. A nearby star might orbit an invisible companion. Its motion can reveal that something massive is pulling on it. And that is where the mystery becomes interesting. Imagine watching a star move through space. It appears to be alone, but night after night, its position shifts in a very specific pattern. It isn't simply drifting, it is orbiting something massive, something invisible. Astronomers can measure that motion and calculate the mass of the unseen companion. If the unseen companion is too massive to be a normal neutron star, but produces no light of its own, a black hole becomes one of the most compelling explanations. But there is another problem. Some stellar objects can imitate the signals astronomers expect from black holes. A dense star can behave strangely. A binary system can distort observations. Gas can produce misleading bursts of radiation. And a distant object can look completely different depending on the angle from which we observe it. That means astronomers cannot simply see something unusual and call it a black hole. They have to eliminate every ordinary explanation first. This is why the most intriguing candidates are not necessarily the brightest objects in the sky. Sometimes the most important clue is what isn't there. No obvious explosion, no brilliant accretion disk, no powerful jet shooting across space. Just a star-like object behaving as though something far more massive is hiding nearby, or possibly inside it. And that raises a disturbing question. Could a black hole actually be concealed within something that looks like a star? The idea sounds impossible, but extreme physics has already shown us that stars can undergo transformations so violent that their original identities effectively disappear. Massive stars can collapse. Their cores can become neutron stars. And under the right conditions, gravity can overwhelm even that resistance. The result is a region where matter is compressed beyond anything we can reproduce on Earth. A black hole. But now comes the part that makes this mystery so fascinating. If a black hole forms in the right environment, it doesn't necessarily announce its existence. It can remain dark. It can orbit quietly. And if another star surrounds it with enough material, or if the system is viewed from the wrong angle, the black hole could remain hidden for an incredibly long time. Astronomers, therefore, face a cosmic detective story. They aren't looking directly at the suspect. They're studying the footprints, the orbit, the light, the missing radiation, and the gravitational pull. Piece by piece, those clues can reveal something that no telescope can photograph directly. But there is one particular clue that could change everything. Because if the strange object isn't merely orbiting a black hole, but is actually hiding one at its center, then we may be looking at an entirely different kind of cosmic object. And the evidence for that possibility begins with what happens when gravity becomes strong enough to reshape the star.
There is a theoretical object that takes this idea to an even more extreme level. It is called a quasi-star. The concept sounds almost contradictory. A black hole sits at the center. Around it is an enormous envelope of gas, behaving in some ways like a star. From far away, an observer might see something that looks like a gigantic stellar object, but deep inside, gravity would be doing something completely different. The black hole would consume matter from its surrounding envelope. That process could release enormous amounts of energy, and strangely, the outer layers could remain star-like. This idea is especially important when scientists look back toward the early universe, when enormous clouds of gas may have collapsed under gravity before normal stars had fully developed. But there is a crucial distinction. A quasi-star is theoretical. Astronomers have not confirmed one. And that brings us back to the original mystery. When scientists discover a strange star-like object today, they cannot simply declare that it contains a black hole. They need evidence. The strongest evidence often comes from motion. Gravity leaves fingerprints. If an invisible object is massive enough, it can force a visible companion into a precise orbit. By measuring that orbit over time, astronomers can estimate the hidden object's mass. Then they compare that mass with what known objects can produce. Could it be a normal star? Could it be a neutron star? Could the system contain two stars? Or does the evidence leave black hole physics as the most convincing explanation? This is how some of the universe's darkest objects are found, not by seeing them, by watching everything around them move. And that changes the way we should think about the phrase black hole. A black hole does not have to look like the giant glowing monster shown in science fiction movies. Most black holes may be far quieter. Some may simply drift through space. Some may orbit ordinary stars. Some may consume almost nothing. And some hypothetical objects could even be buried in enormous clouds of matter, making their true nature incredibly difficult to recognize. The deeper astronomers look, the stranger the boundary becomes between a star and a black hole. A massive star can collapse into one. A black hole can feed on stellar material. And in extreme theoretical environments, a black hole could even become surrounded by material behaving like a star. So when astronomers encounter something that appears to be a star, but behaves in ways a star shouldn't, the question isn't simply, is it a black hole? The real question is, what is producing the behavior we see? That distinction matters because science doesn't solve mysteries by choosing the strangest explanation. It solves them by testing every explanation against the evidence. And sometimes the ordinary explanation survives. Other times, it doesn't. That is when the universe becomes truly interesting. Because an object can look familiar while hiding something completely different beneath the surface. A point of light can conceal a collapsed core. A quiet star can orbit an invisible monster. And theoretically, an enormous stellar envelope could even surround a black hole itself. But there is still no confirmed observation proving that a normal-looking star contains a black hole at its center. For now, that remains one of the most fascinating possibilities in extreme astrophysics. And perhaps that is the most unsettling part. We have become remarkably good at detecting black holes without seeing them,
But the universe may still contain objects whose true identity is hidden behind something as familiar as starlight. So the next time you look into a clear night sky, remember, not every point of light is necessarily what it appears to be. Some stars may be dying. Some may be colliding. Some may be orbiting invisible companions. And somewhere in the darkness, there may be an object whose surface tells us almost nothing about what lies beneath it. Because in the universe, sometimes the greatest mystery isn't what we can see, it's what the light is hiding.